Okay, here we go. Homework help for 3.3. So the first ones, I left the rules up on the board. You have to write, you're given either exponent form, the factors, or standard form, and you have to fill in the other two. They give you an example, right? So then number one, they give us 7, 1, 2, 3, 4, 5, 6, 7. 7 to the 7th power. Oh, I'll do a different color. Let's do red. So this would be 7 to the 7th power. Okay, so we fill in that one, and then you have to fill in the standard form. So what is 7 to the 7th power? Oh, you need to zoom in a little bit. Come here. My bad. There we go, that's better. You can use a calculator, okay? I don't expect you to do this all on paper. But anyway, 7 to the 7th power is 823,543. Okay. Then the next one, you have, they give you 2 to the 10th power, so you have to fill in this and this. You have to fill in the factors, and you have to fill in the standard form. Okay, so then you would just write 2 to the 10th power, so that's just 10 twos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then 2 to the 10th power is 1,024. All right, the last kind is they'll give you the standard form, and you have to figure out the factors. We'll do 6. I think it's a little bit more difficult than 3. All right, so if you're going to factor 625, hold on one second. So some of these you might have memorized, and that's fine, but you can always, if you're given standard form, break it down into its factors. So 625, I'm going to do 5 times 25. But if that's not the one that comes to you, you can start out with 2 different numbers. We'll get to the same place. All right, so 5 is prime. Factor 25. So 1, 2, 3. That's not right. Sorry, my brain's not working today. I don't know if it's because it's Monday or I don't know what it is. Sorry. It's not 5 times 25. That's not even close. It's 25 times 25 is 625. All right, so then factor. There we go. Whew. So then you can go ahead and write out all of your prime factors. So I just have 4 5s. So 5, 5, 5, 5. And if you write that in exponent form, it is just 5 raised to the 4th power. Okay, moving on to the next section. You are given an exponential expression, and you have to write 3 equivalent ones. So let's do, I don't know, number 9, which is 13 to the negative 8. Okay, so there are lots of different ones you can write. The first one that pops into my brain is, oh, I have a negative exponent. That means I need to write the reciprocal. Hold on, so this is our first, second. Okay, so I need to write the reciprocal. So that's going to be 1 over 13 to the 8. All right, that's one example. Well, let's look at your exponent rules. What else do you want to do? I'm going to turn it into number 5. So I'm going to have 13 to the we'll do to the second, and 13 to the negative, 13 not to the negative 10, 13 to the 10. Okay, because if I subtract these, 2 minus 10 is negative 8. So that's another one. Let's also do number 2, rule number 2, which is a to the m. Can you see them? Oh yeah, which is rule number 2. So we're going to go 13 to the negative second power raised to the 4th. Okay, if you multiply those together, negative 2 times 4 is in fact negative 8, all right? So those are just 3 examples. You could use, there are so many more you could do. All right, let's try another one. So that's that was number 9. Let's try, I'll do number 10 just because I know it's going to be a pain. Or it probably will be a pain, which is the 7 1/3. Okay, so I did one of these in class with period 2, or period 5, whatever you want to call them. So 7 to the 1/3, break it down using your exponent rules, right? I like to use the first one, that just pops into my brain first. So what 2 numbers add together will give me 1/3? What 2 numbers add together will give me 1/3? 7 to the 1/6, times 7 to the 1/6, right? If you add those together, you will in fact get 1/3. 1/6 plus 1/6 equals 2/6, and then you could reduce that by dividing by 2, which will give you the 1/3. Okay. Oh, I didn't even think about this one. You could also write it how we were practicing on Thursday, where you change it into a root. So 7 goes in here, and then your bottom number is your index and goes on the outside. So it's 3, or it's the cubed root of 7. You could also do, what have we done? Well, let's do another subtraction one. So 7 to the first power, which is just 7, over 7 to the 2/3. 1 minus 2/3 is in fact 1/3, okay? You don't have to write the 1. If you just write a 7, I'll know that there's an invisible 1 there, okay? That's another one you could do. Okay, we're going to leave it there for that one. And then no, I'll make you do the rest on your own. Okay. All right. So this is where you have to say if they're all equivalent or not, and then give a reason why or why not. So this is number 13. So can we make these look like each other? Using our exponent rules, can we make these look like each other? All right. Whenever I see a negative exponent, that just like jumps out at me. And I'm like, okay, so we're going to use, this was rule number 6, where you have to write the reciprocal. So we can turn this one into 64 times 1 over 2 to the x. If you multiply that out, so you have 64 times 1 over 2 to the x. If you want to put this over 1, you can. 64 times 1 is 64. And then down here you have 2 to the x. Oh, well, hey, look at that. So these two are equivalent. Let's make sure this one is. Okay, because usually I think what they're going to do to you is make 2 of them equivalent and the last one not. All right, so you make sure you test. Make sure you test them all. There we go. So Let's go to this guy. Can I make this look like that? Sorry, I got tired. All right. Wait, did I do this with you? I think I just did this by myself without the camera on. So you're here, and so that's like rule number 3. So you have no, sorry, not rule number 3. The next one down, rule number 4. So you have to put the x, oops, to both of them, which is what I did. So you have 1 to the x, 2 to the x. Well, 1 raised to any power is just going to be 1. 1 raised to any power is just going to be 1. 1 times 1 is 1 times 1 is 1 times 1 is 1 times 1 is 1. Even if you raise it to a negative, like, decimal, let's see. So even if you had 1, oh, sorry. Get ahead of myself. 1 to the negative 5th power. Okay, if you have 1 to the negative 5th power. Okay, so exponent rules, rule number 6, you're going to write the reciprocal. So that's equal to 1 over 1 to the 5th power. Okay, well, that's equal to 1 over 1 to the 5th power. 1 times 1 times 1 times 1 is still just 1. So 1 raised to any power is just 1. Okay, so 64 times 1 over 2 to the x, and then you multiply across. I'll write it down here, and so you get 64 over 2 raised to the x. Ta-da! So they're all equivalent. Okay, this is number 15. Let me write this one a little bigger, 2x plus 1. This is raised to the 2x plus 1. Okay, and this is just raised to 4 to the x. Okay. Are these equivalent? Well, let's start breaking them down. I'll just start with the first one. So looking here, which exponent rule am I using? I'm adding exponents. So which rule over here am I adding exponents? The first one. Okay, so I'm going to rewrite this. 50, I have 2x times 2 squared. Okay? X, 2. That's just 2 to the x, and then 2 times 2 is 4. Right? And then commutative property, you can multiply in any order, so I'm going to go 50 times 4, which is 200, and then that's times 2 to the x. That doesn't look like anything that I have, but we won't. Don't jump the gun. We'll keep going and see if we can manipulate it to match. Okay, good practice. So let's do this one. 25. And then once again, you're adding the exponents, so that's rule number 1. So we can change this to 2 to the 2x times 2 to the first power, which is just going to be 2. So that's 25, 2 to the 2x times 2. Once again, you can just multiply in any order, so I'm going to go 2 times 25 is 100. 2 raised to the 2. Oh. There, look at that. I can't reduce that anymore, and I can't reduce that anymore, and I also can't reduce this. So no, 15, none of these are equal to each other. These are not equal. 15, they are not equal. And it asks you why. You can say because 200 times 2 to the x is not equal to 50 times 4 to the x. Or 200 times 2 to the x is not equal to 100 times 2 to the 2x. Okay, last one I'll do for this section is number 17. Here's what you're given. You have to say whether or not they're equal. So this one I can't reduce. But I can reduce the next one. I will do so in, where's my purple? Aha! So I'm going to call, once again, I'll call this B. So I'm going to come over here. 20 times 1.1 to the negative 1 to the negative 1. That's what it is, all right? So ignore the 20 for now. Which exponent rule is this? It is number 2. You're raising an exponent to an exponent, so you multiply. 20, we're going to multiply negative 1 times negative 1x. Negative 1 times negative 1x, which is just positive 1x, which is the same thing as x. All right, well, so that one matches. Let's see if C matches. So that's 20, 1.1 to the 1/5 to the 5x. All right. Try it yourself. All right, once again, you're using the second exponent rule. So it's going to be 20, 1.1. You're raising a power to another power, so you're going to multiply them together. So 5x times 1/5 is just x. If you don't believe me, multiply across 5x over 5, which is x. All right, so those are all equal to each other. The last section of your homework, you're still just using exponent rules. So you're leaving your answer in exponential form. So do not turn it into a decimal. They tell you to leave it in exponential form. We'll do number 20. No. Yeah. We'll do number 20 first. So you have 5 to the 3rd raised to the 4th times 5 to the 7th. Okay. First things first, 5 to the 3rd raised to 5 to the 4th. Raising a power to a power, you multiply. So that turns into 5, 3 times 4 is 12. Times 5 to the 7th. If you're multiplying and they have the same base, you add them. So that's 5 to the 19th. So that would be your answer. Okay, do not turn it into a decimal. Leave it like that. That's your answer. We'll also do 28. I'm telling you, just have, if you don't have them memorized, have them like written down on a paper next to you while you're working so you can just reference them. Okay? Do R, okay, it's R to the 5th, S to the 3rd, over R to the, oh, just RS squared. Okay. RS squared. These are not the same base, so you can't combine these exponents. They have to have the same base. So there's nothing I can do up here. However, I can even draw a little line here. R to the 5th divided by R. If you're dividing and they have the same base, where is that? Oh, that's number 5. That's this one. If they're dividing and they have the same base, you can subtract. So R to the 5th minus R to the 5th minus R is R to the 4th. And then you have S cubed divided by S squared. So 3 minus 2 is just S to the 1st power, which is just S. Okay, so make sure you're doing only with the same bases. Okay, they have to have the same base. So that would be your answer. Leave it like that. All right. See, maybe I'll do one more. No. 29 is a little difficult, but I'm going to make you try it. So I'll go back and do one more, though. What did I just do? 28? I'm going to go back and do 26. Yeah, YA to the C over B. So it's YA to the C over B. Wait. Over Y to the B, my bad. Over Y to the B. There we go. So all you can really do to this one is you're raising a power to a power. Raising a power to a power. You multiply your exponents. So that gives me Y to the AC over Y to the B. So you would leave it like that. That's it. Well, okay. This is simplified form, but some of you might go, oh, I can also write this Y to the AC minus Y, oh, sorry. Y to the AC, there we go, minus B. And yes, you can, but that's not the simplified form, okay? This is our simplified form, so we're leaving it like here. But yeah, this is also true because this is rule number 5. So no, don't go there. But you're right, that means the same thing. But this is our simplified form. Okay, now I'm done.